Hey geometry class, today we're going to be looking at section 2.5 algebraic proof. So here's where it starts getting interesting. We start out with some equations and things that you should know how to solve, and we put it in a proof format called two-column proofs. And so here are our objectives. We're going to review properties of equality and use them to write algebraic proofs, and identify properties of equality and congruence. So let's get started. Here's our vocabulary. It's our one vocabulary word today is proof, and it's an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. An important part of writing a proof is giving justifications to show that every step is valid. So that's why I like to use something called two-column proofs. We have one side where we make a statement, and then the other side where we give the reason for the statement that we had just made. Alright, here are our properties of equality. We have addition property of equality, which states this right here. It says if A equals B, then A plus C equals B plus C, meaning we can add the same value to both sides of our equation, and it doesn't change much of anything. It just adds two of the same things to both sides of the equation. Same goes with subtraction. We can subtract the same thing from both sides of the equation to change it up a little bit. And then multiplication property equality, same thing, multiplying two things to both sides of the equation. And then division property of equality, same thing, except in this case our value of C is not going to be equal to 0. That has got to be stated because we can't divide by 0, you know that, or else we have an undefined answer. Reflexive property of equality. Reflexive is just the case of being redundant, kind of. We know that A equals A, and sometimes we have to state that, and you'll see an example here in a little bit where we do have to state that. Symmetric property of equality. Sometimes we do have to state this. If we have A equals B, sometimes we have to flip it around and say that B equals A. And the transitive property of equality, it's kind of like our law of syllogism, if you remember that, where we have something like this, A equals B and B equals C. So if we know those two things are equal to each other, then we can say that A equals C, kind of like cutting out the middleman here, okay? Just like that law of syllogism. And then last, our substitution property of equality. It says that if A equals B, then B can be substituted for A in any expression, or the other way around. We can substitute A for any value of B in our expression. Okay, also remember from our previous sections or chapter, we have looked at the distributive property, which states this right here. A times B plus C is equal to A plus B, or A times B plus A times C. Also in your handout, I have for you that something that we have looked at before, another way of distributing if we have a couple of binomials being multiplied like this. Remember, you want to use something called the foiling method, where you multiply first terms together, so AC, outer, that's AD, inner, BC, and then last, BD. Okay, so that's another part of the distributive property. let's move on. Okay, so our first example is an algebraic proof. It said we're going to use algebraic proof to solve this equation and write justifications for each step. So as I said before, whenever we do proofs, we're going to be using two column proofs. One side is for the equation or the statement. That's this side right here. And then our reasons is our justification for the step that we just did. Okay? So let's do this. Here's our equation. We always start out with what we are given, so our equation is going to be called our given statement or given equation. So right here where we wrote number 1, right next to it, our reason for this is that it's given. That's what we normally start out with, is our given information. Okay, 2. The step 2, we're doing the distributive property. So that becomes this right here, 44x minus 8 equals 80. And like I said, that was the distributive property, so that is our reason. Okay. So there's our reason for that second step. Now let's move on to the third. And what I'm going to do here is say let's add 8 to both sides of the equation, because when we're solving equations, we're trying to isolate x by itself on one side. So isolating, we need to add 8 to both sides, and we get 88. So that's the addition property of equality. I'm just going to shorten to addition property. Okay. If you state this, I will understand it means addition property of equality, okay? You don't have to state out the whole thing. Step number 4, what I'm going to do here next is divide both sides by that 44. Okay, so I'm going to kind of do it right here. Divide both sides by negative 44. And this is what we get. We get x all by itself, and it is equal to negative 2. So to go from step 3 to step 4, we ended up using the division property. So that's what we need to state in this step. Division property of equality. As I said, we don't have to state the whole thing out. Just state that portion there, and we are good. We have solved our equation for x, and we have given reasons for each one of our steps, and that is it. That's all there is to algebraic proof. Let's do another one. Okay, we have this equation here, and again we're asked to write a justification for each step as we solve this equation. So here we go. Write the equation down first, and then second, just solve it. If you're not given the equation, like I have given to you already in your handout, all of the steps, and then you're just supposed to justify them, then you can solve this in any manner that you want to. And just as long as you give the justifications for each step and they're correct, then I am good with your method of solving. But here, our method of solving goes to this step right here. It says x plus 14 equals 6x minus 16. And what happened here is we are multiplying both sides and distributing. Well, it's understood to be distributing, but multiplying everything by 2. If you look at it closely, we multiply this by 2, we get x, because 1/2 times 2 is 1. So 1x. Multiply that by 2, we get 14. Multiply that by 2, we get 6x. Multiply this by 2, we get 16. So we're just using the multiplication property of equality in this step here. Multiplying by 2. So multiplication property. Just abbreviate it for me, please. That's all I ask. Okay, step 3. We have this right here, 5x plus 14 equals negative 16. What happened here in this step is that it looks like we subtracted not 5, but a 6x on both sides. Everybody see that? So, to go from step 2 to step 3, this is what we need to state. We subtracted 6x from both sides, so we use the subtractive property of equality. Subtract property. Okay. Step 4. Let's see. We have 5x equals negative 30. And what happened here is we subtracted 14 from both sides to get to this point. So again, we're using that subtraction property. And then our last step states x equals 6, which from 4 to 5, what happened is we subtracted both sides, or divided both sides by a negative 5 to get x equals 6. And that is our division property of quality. Okay, and there is our equation solved out and all the reasons for our steps. And that's what we have to do for algebraic proof. Let's do some more. Alright, example 3, what I have for you is, I don't have the steps all written out on this one, we're just going to wing it, okay? There are several ways that we can go about solving this. I'm just going to do it my way, and if you want to do it your own way on your own paper, great. I am all for that. Just justify your steps for each step. Okay, give me a reason. Alright, what I'm going to start out with is the distributive property. I'm going to distribute that 3 across this set of parentheses right here. So we get 14x plus 21 minus 3x equals negative 1. Okay, so my second step here was using the distributive property. And again, if you want to abbreviate this, I am good with abbreviations. Okay, my next step, I'm going to combine some like terms here. 14 and 14x and a minus 3x here will give me 11x. Okay, so step 3 here, and whenever you combine like terms, state that. That is what you did in that step. So combine like terms. Okay, and step 4, what we can do here is say, let's go ahead and subtract 21 on both sides. Alright, so when we do the subtraction of 21, here's what we get. 11x equals negative 32. So for our justification or reason on this side, we are going to say subtraction property of equality, or just subtraction property. On the abbreviation of subtraction, don't just say sub property. Make sure you go out this far to the TR, because there's the substitution property of equality also. So try to abbreviate those two things just slightly different for me, okay? Okay, our final step, I'm going to say to isolate x, divide 11 on both sides, and we have x equals negative 32 over 11. And that is our final step there, and we use the division property of equality. And we are done. Okay? So let's do some more stuff here in just a second, but let's look at this next slide first. Alright, so in algebraic proofs, we are getting close to something called geometric proofs. And so we're going to take it a step further and use some geometric diagrams in our next couple of proofs. And here we go. I'm just going to read this. It says, like algebra, geometry also uses numbers, variables, and operations. For example, segment lengths and angle measurements are numbers. So you can use these same properties of equality to write algebraic proofs in geometry. So like this right here, this helpful hint says AB represents the length AB, okay? So if we write AB to represent the length of segment AB, you can think of AB as a variable, like x is a variable in our algebraic equations. So AB is going to be representing a variable also. Okay, so let's use that idea in our next proof. Okay, what we are given here is this right here. We are given this diagram, A, B, C, D, those segments put together. And then we're given this much information about it. We are given AB equals CD. So this segment right here is equal to this segment right here. And we are supposed to prove that AC is equal to BD. Okay? So, let's get started. I'm going to write out my 2-column proof. I'm going to call it statements. So statements and reasons. Okay, our first statement, as always, is our given information. So write AB equals CD. Oops, not 2. Put a 1 here. And then we say given. Now, this statement right here that we are trying to prove, that is going to always be our last statement that we make. Is way down here, once we figure out what goes in the middle to get down to our proof that AC equals BD. equals BD. Make sure our reason doesn't say proven. There is no such thing as a reason and then you state proven. No, wrong. Totally wrong, okay? And just get it through your heads right now. Do not ever put in the reasons column the word proven. I will subtract so many points from your test and your homework if you do that, okay? Thank you. All right, so now that we covered that, let's look at the rest of this proof, okay? So statement number 2 here, it says in your handout that we are going to say that BC is equal to BC. Remember, I told you we're going to use that reflexive property, and that's this right here. It's understood that BC is equal to itself. This line segment right here, BC, from B to C, it's congruent to itself. We're going to be using that quite often in proofs to come in this class. So this right here is the reflexive property of equality, but we're just going to say reflexive property. Okay. Step number 3. Well, I'm going to tell you this part right here. If we look at from A to C, that segment there, and then let's look at from D to B, we're going to show that these two segments are equal to each other because we know AB equals CD and then also BC equals BC itself. Well, what if we were to say this right here, that AB plus BC, okay, that is equal to BC plus CD. Okay, so we know this segment right here plus this segment right here is equal to, I'm going to flip it back around, CD and BC. Those two segments are equal. If we add those together and then add the other two together, and see what we've got here is all we did was from this step right here, we added BC to both sides of the equation. See, we're treating BC as a variable, and same thing goes with the length AB and CD. So we are saying this is going to be the addition property of equality. And then lastly, we can say, well, AB plus BC, what is that? In total, that is AC. And then same thing goes with BC and CD. If we add those together, that is BD. And if you remember, AB plus BC equals AC, and then CB plus CD equals BD, that is the segment addition property, and that is the property that we are using here to go from step 3 to step 4. Addition property. There we go. We have just proven that AB plus CD is this right here. If we're given AB plus CD, we can show that AC equals BD. Okay, let's go to the next one and our last proof of the night. Okay, I have all of the statements already written out for you and typed out for you on your handout. All we need to do is give the reasons for each one of these statements. Okay, so let's get started. Says, given this diagram and this information we have given, measurement of angle 1 is equal to measurement of angle 3. That's what the M stands for, measurement of angle 1. And then we also have this in our given, that the measurement of angle 2 is equal to 120 degrees. Okay, so I'm going to kind of mark these on my diagram here. We know that these two angles are congruent. And then we know this one is 120 degrees. You can probably pretty easily figure out what this is supposed to be, even without proofs, but like I said, we are getting used to this proof format for a reason, so let's go along with it. All right. First part I have here for you is that we have the given information. So like I said before, we always start out with the given information. And then also what we have stated here below this given information is measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And whenever we are adding up angles, when we are adding up angles together and we know what they all add up to, this is using our angle addition postulate. So let's state that along with our given. Angle addition postulate. Okay. Now from our angle addition postulate, let's look at this. Let's look at this right here and compare it to step number 2. What we added in was this right here. Part of our given information was that the measure of angle 2 is equal to 120. So what we did was substituted in 120 degrees for our measurement of angle 2. So that right there tells you we use the substitution property of equality. So substitution. See, very close to looking like subtraction property, so don't just put sub property. I need a little bit more information there. Alright, so that was substitution property. Now look what changed from step 2 to step 3. This right here. Measurement of angle 3 and measurement of angle 1 is what it changed to. Well, we can do that. According to this given information up here, angle 1 and angle 3 are equal to each other. So again, we're using substitution property. Alright, so step 4, I'm going to move this up a little bit. Step 3 to step 4, look what happened here. We got rid of 120 degrees. What we did was we subtracted 120 degrees on both sides. So 120 subtracted from 180 gives us 60. So subtraction property of equality. There we go. And now treating our this next step right here, treating this right here, measurement of angle 1 plus the measurement of angle 1, treating these like variables, we can add those two variables together. It's like saying x plus x is equal to 2x. So we got 2 of the measurements of angle 1 right here. So that's how we're just going to put them together. 2 measurements of angle 1 is equal to 60 degrees. So what we did in this step right here is we combined like terms. Okay. Now, next is, now we have this right here to go from step 5 to step 6 here. All we did was divided, say we divided both sides by a 2. We cancel those out, and 60 divided by 2 is 30, and we're left with a measurement of angle 1 on one side of the equation is equal to 30 degrees. So division property of equality is what we used here in that last step. All right. So we found, that's what we were looking for. It says find measurement of angle 1. And that is what we did. We found measurement of angle 1 to equal 30 degrees. And that is actually it for tonight. That was my last slide and my last proof. You're probably happy about that. So let's end it. I will see you all next time I see you in class. Goodbye, everybody.